Okay, so today we're going to talk about how to calculate a mole. Now, a mole is the standard unit in chemistry for the amount of a substance, right? It's kind of weird that we're bringing this up so late into the semester, but this is the primary unit in chemistry because whenever we're talking about a chemical reaction or something that happens or something that reacts, we always need to know the amount that we're talking about. And so the standard amount of any chemical is a mole. So far, we've just been using grams. Okay? So, the reason why we have a unit called moles is because we just can't count atoms directly. Atoms themselves are too small, right? You can't look at, a petri dish or a watch glass and look at an amount and then count them. You just cannot see them. So, we need a way to extrapolate how much of something there is, and we use a different unit, and that unit is what we call a mole. So, the symbol that we'll use for moles, and this is a symbol that you will just, like I said, you'll see it throughout the entire year. The symbol is N. So, if the symbol for a mole is N, how do you figure out how many moles there are? Well, remember what we called formula mass the other day? Formula mass has another name. Formula mass is also called molar mass because molar mass is how many grams there are per 1 mole. So, N, which is equal to grams divided by molar mass, right? Think of this as a 3-variable equation. The number of moles can be found if you know the mass, and the molar mass you can simply find by finding it on the periodic table. If you know the molar mass, and if you know the amount of moles, you can solve for the grams, because this, just like any other algebraic expression, can be manipulated to solve for any other variable. The molar mass can be found if you know the number of grams and if you know the number of moles. So there's 3 variations of this equation, and you'll need them in different scenarios. Question?
Can molar mass be represented by a capital M?
Yes. Yeah. In a lot of college textbooks, molar mass is written this way. Yeah. We're going to keep it simple, though. We're just going to use 2 little crazy because that way it reminds you it stands for a molar mass. Okay. So, example. How many moles of water are there in 18 grams of water? So first, find the molar mass of water. Again, molar mass is the same thing as formula mass. So when you look up water, 1.01 is hydrogen, and you're going to multiply that by 2, and the oxygen is 16.00. Right, so 2.02, 16.00, 18.02. And the molar mass has very specific units. They're grams per mole. Okay, that's important. Whenever you answer a question on molar mass or whenever you use the value of molar mass, you have to use the correct unit, and the unit is the grams per mole. Okay, so 18.02 grams per mole. So how many moles are there? Well, I'm starting with 18 grams. And think of molar mass as a conversion factor. If they're asking for moles, moles is what I'm solving for, so that goes on top. Right? What is 1 mole equivalent to? It is equivalent to 18.02 grams. So really all I'm doing is canceling the grams and converting to moles. So 18 divided by 18.02 is essentially 1. I guess 0.99889, but given that we have to only have 2 sig figs here, we just call it 1.0 mole. So that's another thing I want to re-emphasize, okay? Molar mass is a conversion. And whatever the molar mass is, it can be used upside down or right side up. Moles per x grams or x grams per mole. you decide what you use based on what it is you need to cancel and what it is you're solving for. Right? So if you're solving for moles, then you use the first conversion. If you're solving for grams, that means you have moles and you have to cancel moles, so use the second conversion. It's just like converting inches to feet, just like we did back in Unit 1. All right, how many moles are there in 54 grams? Well, you start with 54 grams. We know the molar mass as a conversion factor. The 18.02 should go in the denominator because the mole unit has to go in the numerator. So 3.0 moles of water. All right. A mole in the lab, when we're in the lab, right, we do lots of weighing on electronic balances. The units on the electronic balances are grams, right? So we weigh everything in the lab in grams, but at the end of the day, we'll eventually need to convert that into moles, and this is how you do that. Okay? Tell me how many moles there are in 99 grams. What'd you get, Nick?
5.5 moles.
Yeah, 5.5. Yep. 99 grams water. A mole of water, 18.02 grams. 5.5, well, with 2 sig figs. All right. You guys okay with converting your grams into moles? Now, you understand that whatever the compound is, the molar mass is going to be different. Water weighs 18.02, but if I gave you another formula like sugar, like C12H22O11, that'd be a bigger number because you'd be adding up more carbons and hydrogens and oxygens, right? But how you convert to moles is the same, all right? So let's try this problem. If we have 10 moles of water, is it enough for the class to drink? So let's say we have a hard lockdown in here, right? And, they tell us to shut off all the lights and, we actually have a survival backpack in here. Do you guys know that? Every room has a survival bag. In the bag is there's a couple of really, really hard protein bars. There's a flashlight. There's an aluminum blanket for warmth. You guys know what I'm talking about? That they give to marathon runners, right? And there's a couple of bottles of water. There's 4 bottles of water in there. Of course, that's for me. I don't know what you guys are going to have, but if we ever need to go into survival mode, you guys are on your own. Anyways, let's say we have 10 moles of water in those bottles. Is that enough? And we have some conversions given here, right? So 10 moles they tell us the serving size is 300 milliliters. So eventually I need to convert this to servings and milliliters. They're giving me the density, but what is the first thing I should do? The density cannot be used right now because I don't have enough information. I don't have either the grams or the volume to use the density. So what could I do so that I could use? Ojan? Yeah, let's figure out a mass. So in 1 mole, it's moles that we started with, so we have to cancel moles. And we know that 1 mole is 18.02 grams. Okay, so the moles cancel. So we have 180.2 grams of water. Now what? What do we do, Nick?
Since 1 gram of water is 1 milliliter, you can just say it's 180.2 milliliters.
Okay, let's do the conversion, right? So 1 gram per milliliter. So, whoops, I did that upside down. We have to cancel the grams, stuff for milliliters. So we know we have 180.2 milliliters. And that is we're assuming that this is exact, so that's not a measurement, so therefore no sig figs. So 180.2 milliliters so far. Last step. How do we answer the question? Well, what's the conversion they haven't used yet? Tia? Okay, so how do I do that? What do I do?
You would divide it by the serving size.
Okay. So 180.2 divided by 300 milliliters. So there are 0.600666 repeating. And initially we had a very sloppy measurement of 10 moles, which only has 1 sig fig. So we're just gonna have to call this 0.6 servings. We don't even have a whole serving. So no, that is not enough for the class drink. It's not even enough for one person to drink. But, you know, we talked about this before. Luckily, if anything were to happen, we're set up pretty well here because we have sinks all over the lab. So we would not die of thirst in here. All right, that's a little bit morbid. Okay. So here's what we want to do. Now that I've shown you how to convert back and forth from moles and mass, I want you to pull up homework 2, and I want us to do a couple problems here in class. So go and download homework 2. It's called Mole and Mass Conversions. Okay, so once you get that, I'd like us to take about 12 minutes or so, and we're going to work on problems 1 and 2, 7 and 8, and 13 and 14. Now notice that they all correspond, right? So 1, 7, and 13 are based on the same problem. 2, 8, and 14 are based on the same problem. So let's break up, spread out, work on those. We'll come back in about 12 minutes, right, and we'll discuss.